what's the difference between touching a curve and cutting through it? In calculus, a tangent line touches a curve at exactly one point, and its slope tells us how fast the function is changing at that instant. Here's what you need to know. To find the equation of a tangent line, you need four essential components. First, you need the derivative. That is the slope function that tells you the rate of change. Then, you'll need to evaluate the derivative at your specific point. Then you'll find the y-coordinate of the point on the curve using the original function. And finally, use point-slope form in order to write your final equation. Master these and you'll be able to tackle any tangent problem with confidence. Let's find the equation of the tangent line to f of x equals x squared at x equals 1. First, let's find the derivative. F prime of x is equal to 2x. Then, in order to find the slope at x equals 1, we'll substitute x by 1 into our derivative function. So f prime of 1 will be equal to 2 times 1, which is 2. In order to find the y-coordinate of the point on the curve, we'll need to substitute x equals 1 into our original function x squared. So f of 1 equals 1 squared, which is 1. So therefore the point is 1, 1. Then we can write the equation of the tangent line. So y minus 1 will be equal to 2 times x minus 1, where 2 is the slope, x equals 1 is the x coordinate, and then 1 is also the y coordinate. So to simplify this, it becomes y equals 2x minus 1, and this is the equation of the tangent line to the curve at x equals 1. If we look at the graph, our curve x squared is here in blue, and at the point x equals 1, you can see that the tangent line to the curve is the line y equals 2x minus 1. In this next example, we'll find the equation of the tangent line to f of x equals x squared times x plus 1 at the point x equals 1. We can use the product rule to find the derivative, or we can expand the function. In this case, let's expand the function. F of x is equal to x cubed plus x squared. Then we can find the derivative. F prime of x will be equal to 3x squared plus 2x. In order to find the slope, we'll substitute x equals 1 into our derivative function. So f prime of x will be equal to 3 times 1 squared, which is 3, plus 2 times 1, which is 2, and that will be equal to 5. Now, in order to find the point on the curve, the y-coordinate when x equals 1, we need to substitute x equals 1 into our original function. So f of x was x squared times x plus 1. Therefore, f of 1 will be 1 squared times 1 plus 1, which is 2. And that will be equal to 2. So therefore, the point on the curve has coordinates 1, 2. In order to find the equation of the tangent line using the point-slope form, y minus 2 is equal to 5 times x minus 1. And we can simplify this. Y equals 5x minus 3. So if we look at the curve, at the point 1, 2, right here, we can see that the line y equals 5x minus 3 is the tangent line at that specific point. In example 3, we'll find the equation of the tangent line to f of x equals x cubed minus 2x at the point x equals negative 1. The same process applies with negative x values. So first we'll differentiate. F prime of x will be equal to 3x squared minus 2. Then we'll find the slope by substituting x equals negative 1 into our derivative. So f prime of negative 1 will be equal to 3 times 1 minus 2, which is 1. Now let's find the point on the curve. So f of negative 1 will be equal to negative 1 cubed minus 2 times negative 1, and that will be equal to negative 1 plus 2, which is 1. So the point has coordinates negative 1, 1. We can now find the equation of the tangent line to the curve at the point x equals -1. And using point slope form, that will be y minus 1 equals 1 times x plus 1. And simplifying this, the equation is y equals x plus 2. That will be the equation of the tangent line to the curve f of x equals x cubed minus 2x at the point x equals -1. So it's the same process every time. The derivative gives the slope, the original function gives the point, and point slope form gives the equation. Master this workflow and you'll solve tangent line problems with confidence. Here's your challenge for today. Find the equation of the tangent line to f of x equals square root of x at the point x equals 4. Remember that square root of x is the same as x to the power 1/2. Use the power rule to find the derivative and then follow the same 5-step process. And please, drop your answer in the comments below. Tangent lines aren't just lines. They represent instantaneous rate of change, which is the heart of calculus. Every time you find a tangent line, you're capturing a snapshot of how a function behaves at a precise moment. Thanks for watching. Please like and subscribe. And don't forget, math success starts when you stay on the fast track.